Hi, Year 9. We're going to go ahead into solving equations with fractions, and we actually already have done a bit of this from today's class. So what I want you guys to just notice is how fractions are written. So there are two ways that we're going to see fractions written. We're going to see fractions written when they're just, you could have, I guess, just 5x might be over 3. So 5x is one term, and it's divided by 3. So our fraction is really 5x divided by 3. And then you might have something else on next to it. Or you might also see, let's say we're adding 5 plus x, and then we're putting that over 3. So there are two very different things happening here. In the first example, the x is multiplying by the 5. So there's a little multiplication sign in there, but we don't write it. We just assume. And then on the second example, the x is adding to the 5. So we're going to have to make sure that we understand the difference between those two because it will affect how we solve our problems. So in an example like this one, I have one fraction is equal to 6. Notice that x is dividing by 3. So in order to get rid of the 3, I must do the opposite of division and multiply by 3. If I multiply both sides by 3, I'm getting rid of this 3. So now all I have left is the x is equal to, and now I must also make sure I multiply 3 times the 6. So 3 times 6 makes 18. Now I can always check my work because if I substitute 18 back in to that x, it says 18 divided by 3 equals 6, and I know that that is true. So I know that I just figured out the correct solution for x. The last example was only one step because all I had to do was multiply by 3, and then I had already isolated x. In the second example, I have two steps that I'm going to have to go through to get the x by itself. So notice that x divides by 3, but now I've also added the 2 on. Anytime we have a number added or subtracted, that is where we're going to start. So we're going to do the opposite of plus 2, which is minus 2, in order to get rid of the 2. So if I subtract the 2, I have the x divided by 3, and then again 6 minus 2, I have to make sure I subtract those two numbers, makes 4. So now I've gotten rid of the 2, which is my constant, but now I need one more step in order to isolate the x. Notice that x is dividing by 3, so I'm going to do the opposite and times by 3. That will get rid of that 3 that I needed to in order to isolate the x. So now I have x is equal to, and 3 times 4 is 12. All right? So these steps that I'm writing down on the right-hand side, I'm writing those steps down because that's what I'm doing to both sides of my equation. And from last year, this was the method that you guys went through where you write your steps in opposite order. Okay? So remember, we think about what happens to x on the left-hand side, but then on the right-hand side, we're actually writing how we're undoing the problem to isolate your x. Just to recap our steps, we want to always identify what is happening to x and then do the opposite operation in reverse order. So again, notice in this last example, slightly different from the last two, x plus 2 is together in the numerator, and then they're both divided by 3. So if I were going to think about what is happening to x here, first x adds 2, and then it divides by 3. So if I'm going to do the opposite operation in the reverse order, I'm going to start by undoing the 3. So since we're dividing by 3, I'm going to multiply by 3 on both sides, which will cancel out my 3 on the left-hand side. So now I have x plus 2, and then 3 times 4 makes 12. Let's do it one more time. I am adding 2 to x, so now I'm going to subtract 2 to undo that last step. That will get rid of my positive 2. And now I just have x is equal to, and I have 10. All right, so I'm undoing the steps that I just went through from today in class as well. So we'll do one last example. Notice that in this last example, 3 minus x is together in the numerator. So the 3 would subtract the x first, and then we would divide by 2. So this happened first, this happened second. So if I reverse my order, I'm going to attack the division first. So if I divide by 2 in the original problem, I'm going to times by 2 to cancel out that 2. So now I'm going to have 3 minus x is equal to 24. My second step is going to be to get rid of the 3. Notice, however, that the 3 is positive in front of the numbers where I want to look to see whether my number is positive or negative. So in my second step, I'm going to get rid of the positive 3 by subtracting the 3. Always look in front. This is a positive 3, so minus 3 will make it 0. That means that I actually have negative x still left over. So 24 minus 3 is 21. Now I'm not done yet because I still have a negative x. So I'm going to need to do a third step in this problem. And what we always want to make sure we know is that there's a negative 1 in front of that x. Anytime you see a negative pronumeral, there's always a 1 in front of the pronumeral. So in order for me to isolate the x, I'm going to notice that I am actually multiplying this negative 1 by the x. So to get rid of the negative 1, I must divide by negative 1. So if I divide by negative 1, it'll cancel out that negative. So I'm just left with x is equal to, and then 21 divided by negative 1 is negative 21. Now I have x completely by itself. So if I ever have a negative pronumeral, I need to pretend like there's a negative 1 coefficient, and I need to divide to get rid of it. So this was a capture of equations that involve fractions. So you guys will get a little bit more practice time with this next class. All right, have a good night.